Hello, my name's Isaac, and this is going to be the first in a series of videos where I'm going to be going through the 2019 Advent of Code challenges and solving them in Dyalog APL. I'm going to be going in blind, so I haven't seen the problems before, and this will hopefully give you a sense of how, what the problem-solving process looks like in APL. Personally, I think it's really good for exploratory programming. So we'll be trying, different things and sort of working with the REPL here to try and get our answers. A couple things before we start on problem one. So I am not going to be, going into what all the different primitives do. You can see up here, you have the language bar. So for Dyalog APL, you have a bunch of these symbols. This is probably the most distinctive feature of the language. And they do different things. So you have grade up, grade down, index of, iota. And so there's existing documentation for these. There's tutorials. There are better resources than me explaining each one of the primitives. Hopefully, if you're curious, I'll link some resources so you can follow along a little bit better. But I want this to be sort of aimed at something of an intermediate user, where we can show, once you're familiar with the primitives, how you actually go about solving these different problems. So disclaimer, I have been using APL for about a year. I am by no means an expert, but I've been playing around doing different code golf and coding challenges. I think it's a lot of fun. So hopefully this video will give it a decent idea of how you'd work with the language. All right, so without further ado, let's look at our first problem. Advent of Code starts off quite slow, so the first problems are generally pretty easy. Part one is anyway. Part two, sometimes there's some curveballs. So for this one, blah, blah, blah. Given module is based on its mass. Mass divide by 3, round down, subtract 2. Divide by 3, round down, subtract 2. And sum of all the fuel requirements. Yeah, okay, this doesn't seem too bad. Alright, so I have already downloaded the input file. So let's take a look at that. po1.txt. And it is indeed a list of numbers. Looks like 100 of them. Okay, so number one thing in Advent of Code is you've got to be able to open files, and then generally you have to parse them in some way. So in APL, we will be using this inget function. And inget will pass you, it will pass you, I think it's a 3-element list. The first one is, the first element in that list is going to be it's going to be a nested list of these different lines, sort of delimited by the new line characters, and it's smart enough to figure out what the new line is based on whether you're on Windows or Linux. So if we take the first element of this, let me turn boxing on, and I also, hang on, sorry, I should have done this before the video, but I guess this might be useful. So we'll turn rows on, dash style equals long, dash cut equals 9, unknown modifier, what was it? Style long, it's fold, okay. Yeah, okay, great. And now, So sorry about that, but now, yeah, this should all come out as one line, and basically we can just scroll to the right to see it. So you can see that this is a nested list of numbers. The problem is that these all come in as strings, so we can't do any arithmetic operations on them, so we are going to do for each, I always forget the character for this, format, and this should give us a list of numbers, and we will assign this to P. P for our problems in general is going to be the input. And so let's start building our solution file, po1.dialog. Yes, please. And so we're going to start off with P. And then we can, we can add up P, we can do whatever. So the problem says divide by 3, round down, subtract 2. So the nice thing about APL, of course, is that you can do operations on whole arrays. So we'll do P divided by 3. This will give you, floating point results, so we can floor it. And then 2 subtract 2. This little guy here, well, it switches around the function to its left. It's what's the name for it? Commute. Yeah, the commute operator. So then we'll be subtracting 2. And it's divide by 3, round down, subtract 2, take the sum. So if we take the sum, we get this, and this should theoretically be our answer. Yep. Okay, so before we go on, let's just let's take this and we will put it in our file. This will be part 1. So we'll just leave a comment there to that effect. All right, part 2. Additional fuel. Oh, yeah, that happens. This is like what is it? Converging series type of deal. Continuing until a fuel requirement is 0 or negative. Mass 14 requires 2 fuel. So the total fuel requires still just 2. Then this fuel requires 216 more fuel. I see. Okay, I think that we can do something kind of fun here, which is we can use the power operator to define a fixed point. So actually what I'm going to do is I'm going to say, let's just kind of roll with this for a second. Let's say that I define this as a function, right? Yeah. And so our function on P will give us this answer, of course. And basically, so I'm looking for additional fuel. All right, let's say that we have, what is the sum of the fuel requirements for all the modules? And also taking into account the mass of the fuel. So let's just say that we have a variable x that starts at 0, right? And FP, right? And let's say that starting with fp, we will apply f until what is this? I think it's alpha. I think alpha is the new one. Alpha equals 0. Yeah. Nope, this is not gonna work. All right, strong interrupt. What am I doing here? Let's just say that I do this like twice. Let's say that I do it 100 times. -3. I don't know. 75 times. Still -3. Oh, right. Oh, because we are subtracting 2. Yeah, that makes sense. So this will be, this is actually going to be less than or equal to 0. Uh-huh. Uh-huh. All right. Now let's say that we basically add w to, it's the other way around. We add w to x, and then we will we'll do fw like this. Yeah, cool. And then x, this has a reasonable chance of being our answer, I think. Let's check. Your answer is too high. Uh-huh. Huh. Okay, all right. Set x back to 0. Let's actually, we'll set it to the empty list. Let's append this to x, right? And then let's see what we get. So this seems right. So x is doing divide by 3, w divide by 3, floor minus 2. Uh-huh. Basically, you would think that adding all of x would give us our fuel requirements, but it does not. Let's say let's just use some of these test cases. So 654, right? Oh geez. 654, set x to Zilda, right? And then x 966, which is correct. Okay, how about this one? We're looking for 5346. If you hear my cat in the background, I apologize. 151, 102, that is indeed high. So what's going on here? Oh, it's required by a module of mass whatever, right? Okay, let's restructure things. So let's say this is just our function, and we're not going to do any of the summation, right? So f sum of p still gives us the right answer, or no. 3376997. That is very weird. Oh, yeah, no, duh. Sorry. Yeah. Okay. Huh. Well, here's basically 100,756. Calculate the fuel requirements for each module separately, then add them all up at the end. This is what I'm not doing. That's what I'm not doing. Okay. Well, so let's think about this. Basically, so I have a function that'll find it. I can use the power operator to basically iterate until, yeah. Huh. All right, here's what I'm going to do. Let's forget all this X stuff, right? So we have F. F is fine. What I'm going to do is, let's take the first element of P, right? And let's say that we enlist it, or ravel it, so that it is now, if we don't do that, yeah, it doesn't have any shapes, so it is now a list. And we are going to do this until we're going to do this until well, we can just do until they're equal, and then we can do something like this. We can do f the neg1 take of w, so basically the last element in the list. We'll assign this to a, and then we can say that 0 is greater than or equal to, right? Then we'll just do w. Otherwise, we will do w a, something like this. Oh, I mean, oh, yeah. right? So we get a list. We get a list like this, and then we can sum it, right? Right. Okay, so now we can do this for each P and basically if you look at this, this is, you know, the difference between the two. Okay, cool. And then if you sum them, you get something like this. Now, what did we guess last time? We guessed this, and we were informed that this was too high. Oh, well, that, I mean, this is even higher. What did I do wrong here? Oh, I just want the fuel costs. I just want the fuel costs. So we'll do a 1 drop here just to get rid of, because the first element is going to be, you know, the module. And this, yeah, it should be close to what we guessed before, but it is less. And theoretically, yeah. Okay, great. Cool. Now, so I think what we want to do, and I'm going to be doing this throughout the videos. First of all, okay, so let me back up. Okay, so function f here is basically our fuel calculation function, and I should have done a better job explaining this, so I apologize. This power operator does something very interesting. It will repeatedly apply the function on its left until the basically the results of the previous application and the next application, when fed through this function on the right, is a 1. So here I'm just using equality. This is called, in general, this sort of power operator match function is called the fixed point, because essentially what we're doing is we are repeatedly applying this function until the result doesn't change between applications. So what I'm doing here is I take in each one of P, which is our, yeah, you can see it pop up. These are our numbers from the input. And we are, this is an anonymous function. You might call it a lambda in other languages, you know, what have you. In APL, this is called a defin for, what is it? It's like define function or something. Anyway, defins have this cool feature where you can embed if statements. So a conditional is indicated by this colon, and everything to the left of it is a conditional, and if it evaluates to 1, then we will just return this. This will be a result of the function. Otherwise, this is a line separator. We will continue. So what I'm doing here is I'm taking the last element of W, I'm applying our fuel calculation function, and I'm assigning it to A. And then I'm saying, you know, 0 if, basically our fuel calculation function, if it's less than or equal to 0, then we return the list as is. Otherwise, we append the new value and keep going. So this is how we build the list. And then finally, I am dropping the first element. So this is 1 drop, and then I'm summing everything up. So dropping the first element is important because that's the mass of the module. And then I'm adding everything. So I'm adding all the fuel costs, right? And that's what I'm doing for each module weight, and then I'm adding the whole thing. And that will give me the result. So my problem, what I was doing before, is that I was calculating the fuel requirements for the fuel required for all modules rather than doing it individually. So I guess one thing that we can take away from this is that it doesn't hurt to read things a little more carefully before diving in. Now, one thing that I like to do, and I'm going to be doing this throughout, is just getting the answer is not quite enough. We want to try and make things beautiful, readable. Anyway, so yeah. So I'm going to restructure things a little bit here. I think basically, so if f is our fuel calculation function, it should work on p. Then if we add it up, yep, this is our answer for part 1, right? So we can replace this part 1 comment here. Yeah, in general, we're going to have to rework our solutions to try and get like some degree of reuse between part 1 and part 2. This will be part 2, and it doesn't hurt to rerun things just to make sure that you do indeed get the answers that you expect. Now, is there any way that I can simplify this? I'm sure I'll think of something clever later. But I think this is reasonable for now. I'm going to be maintaining a repo, of course, with all of these solutions put there. And I may make some modifications or generally like streamline things, but I think more or less this is what the final solution is going to look like. Yeah, so that's APL. And hopefully, now, okay, so for day 1, we don't have a lot of leeway. There's not really that much meat to get into serious problem solving. I will say, for me, I don't record a lot of videos. I don't do a lot of streaming, so it's sort of trying to maintain a narrative while solving these problems is tricky, but hopefully it's something that I'll get used to. So yeah, you'll forgive me if this first video there were some silent spots or things weren't explained very well. I'm hoping one of the reasons that I'm doing this is to get better at presentation and recording videos and that sort of thing. Cool. Well, yeah, so I'm going to leave some resources, as I mentioned, for tutorials and things like that to sort of get used to these different symbols. And by the way, so Dyalog has just changed their license. So Dyalog 17.1, I believe, is what's out currently, and it is free for download. You don't have to register or any of that, so you can just go download it, and it's free for non-commercial use. So please go try it out, experiment, and if you want to try and solve these along with me, I would be very happy to look at your solutions. It's more than one way to solve these things, speaking from prior experience. All right, great. Thanks, and I'll see you next time.